Okay, so today's webinar on basically a very important subject that we must discuss, that is related to the climate change and infectious diseases. As part of the life science team in Atria University, we are taking quite a few very interesting subjects which are related for future generations and upcoming students, which they can relate it kind of uh, throughout their life for now, I think. So the session goes like this. So initially, I give you a brief introduction about climate change and related infectious diseases and its spread. And then me and Dr. Chattopadhyay, our guest today, will kind of discuss some of the aspects of infectious diseases related to the climate change. So first, let me welcome Dr. Shiladitya Chattopadhyay. Dr. Chattopadhyay has a very illustrious career in which he has more than 15 years of hardcore research experiences, including his PhD. So he did his PhD from uh, National Institute of Cholera and Enteric Disease. We call it NICET in Calcutta. And after that, he did his PhD on a very important virus, infectious virus, which does diarrheal diseases called rotavirus. And then he moved to Israel, where he performed his postdoctoral research for more than 8 years in very important subjects of RNA processing and RNA biology, RNA protection, all these fields. So we have a unique combination with the expertise of Dr. Chattopadhyay, in which he has enormous years of basic science research as well as a huge amount of experience to deal with infectious diseases. Welcome, Dr. Chattopadhyay here. So let me first present you towards a PPT, or share you a PPT presentation for today's subject. I'm sharing my screen. Just a second. So I think all of you can see this.
Yeah, it's visible.
Okay, so let me start with it. This is the topic of today's webinar, which is impact of climate change or infectious diseases. So let's go first towards the climate change. So climate change, what is it? So we keep on hearing with different webinars in our normal day-to-day newspapers everywhere that climate change is happening and we are feeling the brunt of it. So what is climate change? So climate change starts with the definition of climate change. So it is an identifiable change in the climate. Identifiable change in the climate can happen in plenty of different ways. In majority of the cases, in the most important ways, it's basically due to the natural processes. But we mostly cannot control the natural processes, which actually kind of create this climate change. But we can control the human activities that changes the climate. So the climate change is an outcome of something we call as different processes or natural processes as well as human activities. So the major activity through which humans kind of are responsible for changing the climate are called the emission of greenhouse gases. So the greenhouse gases happens through natural process as well as through human activities. And the faster we kind of understand that how we can reduce the emission of these greenhouse gases, the better we can control the climate change towards a permissible limit. So the greenhouse gases are gases that are released in the atmosphere. So these are very common gases that we know in day-to-day life, like carbon dioxide, methane, nitrous oxide. So these are different gases which are produced through our activities. The most important way of producing carbon dioxide is burning of or more prominent kind of effect of how carbon dioxide is generated is your burning of fossil fuels. That in your vehicle you burn petrols or diesels. So these are basically some as well as in your for your power plants you burn the coals. All these things generate your carbon dioxide. You have other gases as well, methane, that is done by a process of anaerobic degradation of carbon compounds. You have nitrous oxide. These all gases are created naturally as well as some of the activities of humans. So what these greenhouse gases do is that they trap the heat that is generated in the earth. In the natural process, if you have minimum amount of these gases, what Earth does is the heat that is absorbed through the solar system, through the solar power, that gets also sent back, radiated back towards the space in a natural process. But as greenhouse gases, more and more greenhouse gases like carbon dioxide and all the other gases that I just spoke of, you have more and more of those gases, you have more and more trapping of those gases, which makes the climate warmer and warmer. So now let's give you a kind of a perspective of how greenhouse gas emission is getting increased. So this is a chart that is from 1970s to 2010. So as I told you, greenhouse gases are of different kinds. Carbon dioxide by fossil fuel burning, carbon dioxide released through agricultural processes, you have methane, you have nitrous oxide. All these gases, you see that in the graph compared with 1970s and 2010, how much increase it has, how much it has increased. So it was like 1.3% increase till 2000, and now it's increasing at an alarming rate of 2.2% till 2010. Now the 2020 figure is 2.4%, 2.48, or close to 2.5%. So until and unless we can kind of slow this emissions, the environmental degradation will go to such a level that we will be kind of, the human population will be trapped in this climate change conundrum. So now coming to the effects of these changes, then the climate change, we all know that are kind of responsible for rising the sea level water, because your icebergs are melting due to kind of high temperatures. Now, if we stabilize also today the emission of the greenhouse gases, we are very, it is very unlikely that all the problems associated with climate change will cease to exist. You will have some of the effects which have become entrenched and permanent, but some of the effects of climate change can be controlled or maybe slowed down. So as a life science department, we are much more interested in the effects of this climate change on your ecosystems and on health. So the ecosystems, the climate change, it has been shown, are kind of destroying your coral reefs. In the very nearest place that we have is this Lakshadweep, where in our country you have very nice coral reefs, but there are plenty of reports which is showing that there are changes in these coral reefs are happening in very nearest location of us, as well as other coral reefs like you have in African continent in Zanzibar and like those places, Australian coral reef, all are kind of getting destroyed due to this climate change and its impact. The wildfires have increased. You can see everywhere in this world, be it California to India to Australia, wildfires are rampant, and kind of 30% of the species are at risk of extinction due to rapid changes in ecosystems. Because of this climatic condition is changing and your earth is becoming warmer and warmer, lot of different species are kind of getting extinct at an alarming rate. Now, I will go through the effects on health. So the climate changes are also affecting the health of humans. Due to heat waves, a lot of people are getting sick, heat stroke and other kind of diseases. Apart from that, there are natural disasters which are causing huge amount of injury to humans, be it floods, cyclones, tsunamis. All these things are climate change related issues or climate change related problems which are actually creating a lot of health hazards, as well as increased risk of water and vector-borne diseases that the humans are facing. So I will be today in today's webinar kind of quite concentrate. We will concentrate on the last point, which is water and vector-borne diseases, which comes under infectious diseases, and how they are kind of getting how they are kind of an increasing due to the climate change and its risks. So now the first thing, that's the health diseases that we can see are related to the climate change, are the increased risk of contact between some of the animals and the humans. And the more and more the animal species which were previously having a separate habitat and quite different habitat than humans, they come into contact with the humans due to this global climate change, you will have something called zoonotic transmissions. So zoonotic transmissions are the transmissions which actually comes from your animals to the humans. and there are some deadly diseases that can also that are part of these zoonotic transmissions. So people are getting more and more rabies because the rabies is expanding to new geographic areas or in countries. So there are some wild animals which used to be very happy in the wild, but due to, say for example, I'm giving you a kind of a example in which increased wildfire are displacing animals. Increased wildfires are displacing animals due to this global warming and your climate change, and ultimately the animals are getting closer to the human habitat, and in that process those animals and human are contacting with each other, and you are having you are getting sick with different diseases which are basically animal diseases. Rabies is one of them. Now some of the frozen areas in the Arctic as well as in Himalayas, you will find that the icebergs are melting at an alarming rate. So in this process, these frozen areas, the normal habitat of these frozen areas are getting extinct, and these are getting taken over by certain other kind of animals whose population is increasing. I'm giving you an example. And a small animal called vole, it looks like a mice in Alaska. They are kind of the carrier of a disease called Alaska pox. So the Alaska is an area which is very close to the North Pole and a part of America. But due to this increased kind of increased temperature and your climate change, the natural habitat of those areas are getting replaced by other kind of animals which are not the original kind of the original habitat of those areas, and those population increases of the other kind of animals are creating some of the zoonotic transmissions. And then you have some of the deadly threats like Ebola, monkeypox, Rift Valley fever, which are spreading to new geographical areas. I think a couple of years back, all of us almost have heard about these two diseases called Ebola, monkeypox, which are not kind of the diseases. Ebola was an African continent disease, and monkeypox was also an African continent disease. But due to this kind of climate change, they found their way into different other geographical areas. Like monkeypox, a lot of European countries got monkeypox because generally in normal climatic condition, European countries are much more cooler, so the risk of monkeypox spreading was much lesser in European countries. But due to the warm summer days, now the European countries are getting, due to climatic change, this monkeypox have spread it to Europe at least once last year. Ebola is one another such case which actually found its way into the American continent. So you have plenty of Ebola cases in American continent. There is also Rift Valley fever and other diseases which are finding its way into newer geographical areas, which were never the case previously. Now, the waterborne diseases. The waterborne diseases are of different kinds. In our country is the world capital of, or the subcontinent itself is a world capital of waterborne diseases, be it cholera, be it other kind of diarrheal diseases, be it other kind of viral diseases which gives you stomach upset or diarrhea. So all are kind of the diseases which are prevalent in India and the countries around. So how climate change are basically increasing the risk of waterborne diseases? The classic case is a cholera. Other diseases are also the same. I'm just giving you an example to make you understand how they are kind of increasing the risk of these diseases. So there are some facts and figures about cholera. Cholera is an increasingly as a disease which affects close to 4 million population in the world. Each year the data varies 10 to 15%, and a lot of people kind of, and specifically the children, are get dies due to cholera infections. So this is a life cycle of cholera. I will not give you a complete details. You can see that in the what is it, in the PowerPoint itself, in the slide, how cholera spreads. But I wanted to focus on a point that how cholera risks are getting increased with increasing climate change. What we are getting is a lot of floods and other kind of disease, other kind of natural disasters. So what these floods and other kind of natural disasters, you have floods, you have iceberg melting, you have flash floods, all these things, what they are doing is basically spreading the cholera very fast from one place to the another, because it is spread through basically water contaminations. So if you have contaminated water in which cholera, Vibrio cholerae, the bacteria for cholera is there, what will happen due to floods and poor sanitization condition due to floods, the water becomes too much polluted with this kind of bacterial diseases, and ultimately, as people start suffering after a few days of flood due to water contamination of cholera bacteria. So this is a classic case of how climate change and floods related to climate change can somehow increase the risk of your diarrheal diseases. There are other diarrheal diseases we will talk today with Dr. Chattopadhyay and me, which are not only cholera. There are other few other viral and bacterial diseases like salmonellosis, shigellosis. You have E. coli related diseases. You have rotaviral diseases, which are getting rampant due to this climate change related issues and increased risk the population is facing for these kind of diseases. So this is waterborne disease. I am giving you an example of cholera. Now we will move to something called the vector-borne diseases. The vector-borne diseases, this year I think the Bangalore and most of the cities faced, some of our colleagues also became sick with something called dengue. So dengue, chikungunya, malaria, these are all vector-borne diseases that we see around us. And with the climate change, what we are getting susceptible to these vector-borne diseases. I just give you a few examples. There are direct vector-borne diseases, like there are some diseases which can be caused by tick bites. So although the percentage is low, but these are increasing. So because how these vector-borne diseases are getting proliferated due to this climate change is that different species they are susceptible, they are what say that these species their survival are getting benefited due to this climate change. The time span, say for example, of a malarial disease or a viral disease like chikungunya or dengue, used to be 2 to 3 months time span during the rainy season in our country. But now, due to this untimely rain and untimely kind of events that are taking place, the susceptibility period for these infections are getting more and more. Like starting from March to October, you will find this entire time span the population is getting susceptible through malaria, dengue, chikungunya, this kind of diseases, because your vectors are getting proliferated much more, the mosquitoes and other kind of tick-borne carriers. Similarly, the pathogens are also getting very nice incubation temperatures, as they used to get only for 2 months previously. Now they are getting for 6 to 8 months. So you have a continuation of this cycle whereby the vector-borne diseases are getting facilitated. The viral replication cycle is also getting decreased due to favorable weather conditions, in which you have, I think most of us know that our body temperature is 37 degrees centigrade. So if you have 37, 38, 39, 35 degrees centigrade throughout the year for a prolonged period of time, not that only it affects our activity, it affects the activity as well as replication cycle of different pathogenic bacteria and viruses. So they get the favorable condition to proliferate under that circumstances. Just giving you a kind of a look of what are the different kinds of diseases. I will not go to the great detail about it, but the slides in fact tells us that these are different kinds of mosquito-borne diseases, tick-borne diseases, and other vector-borne diseases, and how they are proliferating and their geographic locations. You have malaria, mainly Africa and Southeast Asia as well as Southern Asia. The cases per year has surpassed 220 million, that means 2.2 crores among different populations in these areas, and they are on an increase due to this climate change effects. Similarly, dengue it's about 50 million and it is increasing at an alarming rate due to the climate change related events. Other diseases like your tick-borne encephalitis, also it's not very prominent right now in India, but it is more prominent in Russia and northern China, Mongolia, because all those areas, they used to be very frozen areas. But due to the climatic change, what they are nowadays getting is very smaller and smaller layers of ice and smaller and decreased ice falls. So their temperature and climatic conditions are also getting favorable for the tick-borne encephalitis and other diseases. I will not go to the detail of it. So if I give you a kind of a snapshot, our survival to this climate change and related pathogenic diseases are directly an outcome of how about our social vulnerability is. Social vulnerability are made up of three factions. One is exposure, the other one is sensitivity, and how our adaptive capacity is. The exposure is that how much are we getting exposed to the climate related problems like rainfalls, temperature rise, precipitations, iceberg melting. How are we exposed to the events related to climatic change? Then we have the sensitivity, in which how we are getting kind of a sensitive towards this exposure to these changes, in which you have wastewater treatment systems are there or not, water treatment and delivery systems are there or not, how our housing conditions are, how our demographic situation is. So these are all our sensitivities towards those problems. And then we have the adaptive capacity. Although we have the sensitivity towards that, how we are adapting to these problems, our capital, governance, education, all comes under this adaptive capacity. And if you have better adaptive capacity, your vulnerability is lower. If you have lesser adaptive capacity, your vulnerability is much higher. Now, what can we do? So there are a lot of things, and this is the area in which we will have our kind of conversation with Dr. Chattopadhyay. Climate change, what we can do about the climate change. So I'm just giving you a small data, but I think the way out we will discuss during our conversation. So as we can see that the energy related, so the energy related uh, effects which are the major contributor to these greenhouse gases in greenhouse gases in the world. So 64.5% of the greenhouse gases are getting generated due to our energy consumption and energy related needs, be it your transportation, fuel combustion, manufacturing, electricity. All these contributes the major portion of your greenhouse gas emissions. So these are all human made things, or humans need thing. So it's something that we can work on in these areas, whereby we can reduce our energy consumption, as well as we can sort out different pathways by which we can generate a clean energy kind of a thing. Thank you. So now we will have a conversation, as I give you a brief idea about how climate change and how greenhouse gases causes the climate change. We will kind of now go to a conversation with Dr. Chattopadhyay, who is here with us.
Thank you, Dr.
Stop sharing.
Abhishek Sinha,
Yeah.
for your wonderful presentation and introducing us to a very important area. And this area actually like unites all the areas of science. So nowadays we are talking about interdisciplinary science and multidisciplinary science. So this is one area actually that should unite all areas of science and all sectors of the people to work on and circumvent this problem. Yeah, so with your wonderful talk, so now we can move on to our discussion.
Yes, yes, yes. So we are very excited to have you, Dr. Chatterjee, here.
Thank you
So
so much.
I
And
try to present, although this is not a very core area of my research presently, but I try to study the effects of climate change and how can we kind of circumvent some of the stuffs that are happening around us due to this climate change. So my first question to you will be, I presented some of the bacterial, some of the viral, some of the vector-borne diseases. Your expertise lie on specifically on the viral side, it's the viral infections and specifically with some of the viral infectious diseases.
Mhm.
So your I will like to understand your perspective on the role of climate change, specifically on upcoming virus infections or viral infections.
Okay, so the effect of climate change on the virus can be multifaceted. Like some of the areas that you already talked about, vector-borne diseases that usually what was restricted in one place earlier is now spreading to a more like wider places, like for example, dengue or other flavivirus infection, like Zika virus infection that was also a pandemic in Mexico and later also part of US. And recently there was a case of Zika virus infection, I think also in Karnataka recently. So and every year actually we heard about many unknown diseases. If we just go through the newspapers and all kinds of media, you will find that there is a that people are suffering from an unknown diseases, and most of the time why the disease is unknown, probably in many cases because it has come from another source, or that disease actually that kind of disease never happened to that area earlier. And major in a major way, the reason behind it is climate change. And why is this climate change is so important to us? It's because the climate change, for example, the change of temperature and the constituent gases in the atmosphere, it's mainly a contribution of last 100 years, right? After the industrialization that happened all over the world, especially in the Western countries, it started, and then it is now actually occurring all over the world, right? Because we know that also in Africa, like many big land areas are being they're bought by big industrialists from different countries. I'm not naming the countries, but they're buying that area and building big infrastructure there. So we're like, and due to industrialization, the rise of temperature, we know that the data is it's around like 1% rise of temperature on average. But if we go to in smaller areas, because if we go to a village, like now I'm sitting at Kolkata, and I have certain temperature, and I'm experiencing certain temperature. And if I go to a village not very far from here, maybe the temperature will be completely different. Not maybe, it will be completely different. And so when we're talking about the average temperature rise, it's a temperature rise all over the world together. But if we go to areas where most of the people live in the cities, where the population density is the highest, where the temperature rise probably is much more than this average temperature rise. So actually, we are in a much worse condition than we think, because then when we have much higher temperature, and how it can affect, as you already mentioned, that it can affect the vector-borne diseases, and it can spread very easily. And uh, when there are a huge amount of people in one place, so we know that 40% of the people in Mumbai, they live in slums. It's an official data, so it's around 40% people live in slums. And the definition of the slum is that they don't have proper sanitation, so they are very prone to diseases in that area. And actually the Dharavi slum is one of the hotspot of COVID infection as well, and many cases were reported from there, and who knows how many were unreported. So, and when we have such areas, the people that live in that area is suffering, but also they are acting as a kind of reservoir or a place where it from where it can spread to other areas as well. So it's multifaceted. And another thing I think that we should also consider that we are a result of like a million years of evolution, and things earlier than pre-industrialization era, things changed very not very rapidly, very slowly. Technological advancement was very slow. So changes were very slow. But when we changing the things so rapidly in this industrialized era, so all the climatic change that we experience is very rapid, and it's impossible for us to change because we are because evolution does not happen in 100 years. It takes million of years to evolve. So we cannot change, so there is always a lag than what we are creating and what we are. So this lag will be there, so we have to cope with this lag. And why I'm talking about this is because we are talking about only the viruses that can change its habitat and come. So there can be many ways it can happen, but also it's because we have an immune system which is designed to work in certain temperature, and because we are changing the environment, so it will not act the way it was designed. For example, another area is the microbiome that we have in our body. For example, the gut microbiota. It's very well explored area and a very important area of research now. So those who don't know, the students, if the students are there, so I will tell them what is microbiome. So when like inside our body or also in other places, let's talk about our body. We harbor or we keep many microorganisms in our body. For example, our gut, it's a very big reservoir of many microorganisms, small bacteria or other microorganisms. Okay, so we have a certain pool of this microorganism there, and they have a very it is they are very well connected to our brain as well. Like there is the so-called gut-brain axis that work, and it is also known that these microbiome is also influencing our nervous system in a very important way, and they can also be behind many neurological conditions that we face. So if the if in the atmosphere we have different kinds of gases that is different in the concentration, then it can also influence how the microorganism or the bacteria will react to these environmental changes, also the temperature, and they can produce different kind of chemicals, like what call it metabolites, because it's a effect of metabolism. So these chemicals then can influence our body in a different way, right? So and the moment they are secreting different chemical, then it can also influence the microbiome itself. It can then change the ratio of different microorganisms. So it like the effect can be many different ways. So it the it's a multifaceted way that it can affect us, and we should be very careful how and we should do something to resist it. And as Dr. Sinha already showed that majority of this the problem, the climate change, is due to the energy source, like the energy that we create for our house or when we transport. It's one of the major problems. So we have to find alternative sources of energy that will not create these problems. So let's hope that we will have this in near future, and all the alternative source of energy will also be useful or and will generate enough energy so that we can replace the other sources.
So, just to take kind of the cue from your answer, that is, we need to be protecting ourselves from these infections, which are emerging infections. So there are a lot of different ways, like finding newer antibiotics, finding newer antivirals, or vaccination. As you saw that during our COVID pandemic, we had the vaccination actually protected a huge number of population from COVID related deaths. So like
Yeah.
other diseases like malaria now have a vaccine, as far as I know, which are under limited use. Sorry. So vaccination is a strategy which actually people are thinking to kind of use wholesomely into for protecting ourselves against emerging infections. So the reliance of ourselves on vaccination, when it will become an over reliance on vaccination, that is something I want to kind of discuss with you. That is, we are relying on vaccination, so it's one kind of strategy.
Yeah.
Can it become an over reliance within the time span, and we can think that we have taken multitude of vaccinations to protect ourselves, which are actually playing with our immune system and creating its own problem.
Yes, 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 definitely. Because and one of the major challenge that you already have mentioned, that one of the major challenges that new viruses or new infections are coming to us, right? So if something is new, first of all, like what happened during the COVID pandemic, that we were we were clueless at the beginning. We didn't know what to do, and we at that time we didn't have a vaccine. So first of all, we it always takes time to create a vaccine. Even if we create it in very very short time, even that time is it will take like 8 months, 9 months, 10 months, and that time will be enough for any virus or any uh, other infection to kill or affect a huge number of people all over the world. And another thing is that like mm, because for some diseases we already have a vaccine, but maybe that disease was already was that organism was confined to one place. And that, because the way virus mutate, it also depends on the host is the one where the virus come and attacks, right? So if we also change the host or expand the host, and the virus now can spread to a new group of people that were earlier were not used to infected by that virus or organism, then they will not be as prepared as us, and the virus will also get a chance to mutate in that area, in that new genetic makeup, because the genetic makeup will be little bit different in those people probably, and that can also affect the mutation of the virus. So we will have a new virus, new variant of that virus, not a new virus, like what happened during the COVID. Like it starts spreading in different areas, and then it's getting we are getting different kinds of variants. So when we have more bigger habitat or more bigger area where it can spread, then it is spreading to a new group of people, and then it's more chance that it will have a mutated virus. So the old vaccine that we have created will not work in many cases. It will not work. So that also can be a problem. So, and another problem is that why we are relying so much on on vaccine about viruses. So the main reason is because the virus mutates a lot. Mutates, it means that it changes its nucleic acid sequence, DNA or RNA sequence, mostly the RNA sequence, because the RNA viruses are the one which is causing this zoonotic transmission, like it jumped from an animal and comes to us, and then over the time it can acquire different mutation and start spreading. So it's a problem, like it's always it's a threat that we will have a new virus and the vaccine will not work. and we have a new, and it will mutate, so that we have a we earlier probably had some kind of uh, mm, drug or therapeutics against that virus, but it won't work because it already acquired some mutation. Like it happened for one of the drug that were used, that were approved earlier against HCV, but it stopped working because the virus has mutated. So later they had to withdraw the drug. So these things can happen.
So first of all, I'm pretty happy to tell you that, or let you know, is that as a part of Atria University, we are tackling these areas through multitude of actions. You may be very happy to hear that we have courses designed which works on newer battery technologies. We have courses here which design on interspecies protection and kind of uh, ecosystem protections. We have courses which actively working on alternative energy sources, which, but the ultimate thing that we want to tackle is the climate change and climate change related effects, be it physical effects, be it infectious disease, be it ecosystem damage, all the aspects related to climate change. We are very happy that as part of this new university, we are trying to tackle it through multitude of different actions. So we have questions now. We will go
Excellent.
for question and answers. I see that Dr. Anupama has raised her hand, so I
Yeah.
will be happy to take the questions. You can directly pose your question, Anupama. Yes.
Yeah, thank you. Thank you, Abhishek. To both of you, this question I'm posing. The vaccine, I mean, there's been a lot of debate and discussion around the vaccines, especially in the light of COVID-19 and the pandemic and whatever followed. And before that, also in the US, it's not so much in India, but in the US, there's a very strong anti vaccine lobby. There are people who don't even take the basic vaccinations which are given to children here quite, we follow it quite strictly. So in the light of, like, when you explained, like, there are going to be more and more newer likely diseases to which we have not developed the resistance to it, and you have the anti-vaccine lobby on one side. How would you, I mean, see the scenario unfolding?
So first, Sheila, first I am taking it. Huh?
Yeah.
Yeah.
Okay. Sure.
So I think for me, the one area where vaccinologists have started to work very recently is the vaccines interplay with the immune system. It's an old subject, but something that I came to know, that is which vaccine combinations you can put in a single body. So say for example, vaccine A, B, C, D, E, F, because the amount of infectious disease you are like to kind of acquire now, whether all the different, say for example, you have 50 infectious disease around you, and for that 50 vaccines are available. Will it be possible a human body to get the 50 vaccines and all the vaccines will uh, work accordingly what they were designed for? So this is a newer area where as many vaccines as rapidly the vaccines start to come to protect yourselves, the science is going to go to that area as well, whereby you can see that this vaccine can go to combination with this vaccine in the body, whereas the other combination cannot work under that circumstances, or it will have an adverse effect on your immune system. So this is an area where research, I think, at a very premature stage, which actually shows you the combination of vaccines you can take. Like, say, for example, in doctors do not give you doctors always give you a combination of tablets and omit some of the tablets because you are already taking some other tablets, which is it's called drug reaction or adverse reaction of drugs. So different drugs can adversely react you when they are taken in combination. So like that, this is an area where I think very soon we will indulge into very cutting edge data, which will give us that with mRNA vaccine of this kind you can't take this vaccine. So in that way you may have to fix very in future that what kind of vaccination regime that you want to go through. And we may have to, that's why my question to Sheila was, and he answered very beautifully or eloquently, that is, we may have to now, our vaccine reliance can become over reliance. Vaccine is a technology which we are thinking that it will work like a magic, but the problem is that soon you can't take 50 vaccines of 50 different pathogens. So you may have to combine different vaccines in a different way, and for other diseases, you may have to go for therapeutics. So what will be the combination? That is very important to kind of find out. So Sheila, if you want to elaborate.
Yeah, so to answer your question, like one part Abhishek already discussed. So another part can be like there, like most of the time when we are targeting an microorganism, we usually target the microorganism directly. So now there is another view where we can target, instead of the microorganism, we target specific factors in the host. And maybe we can identify some common factors in the host that without maybe for like the viruses, when they infect a host, sometimes they like show like use the same kind of pathway. I mean, I don't want to use too much jargons. So they use certain factors in the cell, and if these factors, if we can find some common factors that can be targeted, then we can have some therapeutics that will be useful not against one virus, but different viruses. So in that way, we can reduce the amount of vaccines that we or the therapeutics we can take. And actually, like for example, I'll give you an example. Like we have a flu-like symptoms. And so the flu-like symptoms or flu-like illness, like what the people call, so it can caused by different kind of viruses and also some bacteria. So if it's like if we first have to go and see what the organism, which microorganism is causing the disease, then we have to find like which drug we can use against that microorganism, which will take time. And also time is very important, and it's also a lot of resource. So if we can find something that will, okay, if we have this kind of symptom, then probably this is this group of organism, and this group of microorganism can use one maybe like there are 5 factors that they all use for their own benefit. So we can target that and control this disease. This is one way. And another way, like talking about the anti-vaxxers. So it's a real problem now, the anti-vaxxers, and also some people think that the earth is flat. And earlier we thought that relying on, like when we will have more advancement in science and technology, we will have less people that will believe in this. But actually they're using technology in a different way to show that their point is true. So it's actually like backfiring us. So I mean, the only thing we can do, like we can uh, create more awareness. And I think these problems arise because not they are like because of half truth, like they are showing things in like in a like they're not disclosing everything, either intentionally or without knowing. So we have to spread this awareness more. I think that's the only way we can cope up with these people.
So if anyone else has any questions, we are happy to take.
Thank you to both of you. That was, I think, a comprehensive answer.
Thank you.
If anyone has any question, he or she can raise the hand. And if not, then I will like to thank Dr. Shiladitya
I
Chattopadhyay. Yeah.
want to like like say 2 more points that
Yeah.
I think is important. One was like um, one concern that arises in recent years. Like many people are talking about it, but no one really know what the answer is, because there are people that are saying theories against that also, is that because all the icebergs are melting, and many places there are permafrosts that probably are, some are melting and some will melt if the temperature will keep on rising, then these frozen areas or this ice, they are also trapping different prehistoric microorganisms and maybe some viruses as well, right? And I don't know, like maybe some of the bacteria, they might have a survival issue, like they might survive, might not survive, but still some can survive. But the viruses, probably they will survive, and some of them actually can start infecting us. And this area were frozen for many like million of years. So suddenly, if we were exposed to this new microorganism, then it can be very like it can be disastrous, because
Yeah,
our
so
immune system don't
we
know
may see
them at
some of
all.
the we may see some of the older virus which we thought that are non-existent, which was
Yeah,
there millions of years ago, may reoccur again.
yeah.
Yeah. Anything else? Yeah. The other thing?
Another thing is that I saw in one interesting data that since 1970, the occurrence of cyclones in Bay of Bengal and Arabian Sea, it has reduced. Like number has reduced, but the intensity increased, because with the sea temperature rising, the intensity of these things increases. So, and you can see that how many of the cyclones that actually hit to this part of India, the eastern part of India, some of them, like in Odisha and West Bengal, and some actually went to Bangladesh, but they affected this area. And we know that it's a very major problem.
I think his image is frozen, no?
Yeah, it's frozen. Yes. Just wait a second.
Yeah.
Yeah. You can progress. Yeah, sure.
Okay. So actually, and when this occurs, we know that there is a cause, like there is a flood. Usually there is a flood, and when there is a flood, as he already mentioned, that one microorganism that was sitting in one place can easily go to another place, and because many of the people in India are reliant on surface water,
Hmm.
so the surface water will be easily contaminated. So the rise in temperature in the sea will increase the intensity of the cyclone, and with the increased intensity of the cyclone, there will be more flood, and there will be increased incidence of diarrheal and diseases
Hmm.
in that area. And actually, USA did a study starting from 1996 to 2018. They just published it in Emerging Infectious Diseases Journal, and they showed that whenever there is a this kind of situation, the amount of E. coli and Legionella infection has increased 50%.
Yeah.
So they actually did a complete study that actually showed this. And we know that because our area is much more disease prone, so if something like this happens with more intensity, then we are in a much bigger problem.
You were right. You were right. It's really the case now. This is waterborne infections in specifically eastern coast and western coast. In Gujarat also last year, there after the floods, there were some of the infections which was quite rampant. Some of the waterborne infections. So with that, we will kind of
I'd
yeah,
like to
anything, yeah,
request everyone to turn on their
yeah,
videos. Jagdish, would
please.
you be taking a picture?
Okay, ma'am. I'll be taking the picture.
Yeah. Can everyone turn on your videos? I don't
Okay.
know if
Thank
Harshit
you.
and Celestine are able to do it. Let's take taken.
Take a ma'am.
Yeah. All right. Great.
Thank you, Shiladitya, for joining us.
Thank you.
Despite I know that you were very busy during this time.
Thank you.
So
Thank you so much.
I like to thank you wholeheartedly for joining for today's webinar from on behalf of Atria University, and we will like to have you for future events as well. I will
Sure.
like to thank all the participants in this webinar. I hope that you learned something which were not from your core areas and maybe helping you in future. With that, we will like to finish today's webinar. Thank you all for joining.
Thank
Thank
you.
you,
Thanks
Dr.
for
Shiladitya.
inviting.
Thank you.